Hello guys, today we're gonna learn how to get data from official worldwide website platform World Bank Open Data. So we need to write World Bank Open Data in Google first, and after writing this, we're gonna get that window. So we need to press countries button as we need their data. So then we're gonna get that view. So you have your own given country. So mine is UK, so I'm gonna press U button. So and then after pressing U, you're gonna get that you're gonna get countries that starts with U. Mine is United Kingdom, so I'm gonna press this, and that's the view that you're gonna get after pressing it, and that's all our the data's information that's been collecting from the beginning of the UK. I'm gonna say so. Just to get the data, we gotta download it, and we need to download this in Excel format, guys. So we need to press this once, and here guys gonna be downloaded in there, and after it's downloaded we're gonna open it. So we're gonna press this button there, and that's our data, guys. So yeah, that's it. That's how you're gonna get your data, just to make the file in Stata. Bye guys. Hi guys, today we're going to learn how to work with our Excel format of our data, which we downloaded from World Bank Open Data. So first thing that we're going to open our Excel, Microsoft Excel. So after opening it, we're going to get that Windows. So here we have 3 pages, which is data, metadata countries, and metadata indicators. So the page that we need is just data, and we're going to delete other 2 pages. So how can we delete it? We're going to press the right button of the mouse and press delete button and say delete. Same thing with the indicators. So after deleting it, we end with this page. End up with this page. So how can we find or choose our data? So just to choose our data, or you can say your variables. So first we gotta decide on what to make research about. So mine is about transport service, food imports impact on transport service, and GDP per capita. I'm gonna choose those data here. So first thing that we all gotta choose is country name. Here we're gonna say the years. So here we can see it, years. So yeah, how can we choose it? We're gonna go over 4, press the right button of the mouse and say copy there, and we're gonna create our new list, which we need because we need to make our data. That's why we need it. So we make this data in a column. So just make it in a column. We're gonna go over first block and press the right click of the mouse, and then we're gonna choose the fourth option of pasting, and yeah, here we go. That's how you do it. And my next variable is going to be about transport service. As I told you, I'm going to say copy, go to my list, do the same thing with this. And then we're going to choose here food imports. You guys also need to choose your own variables. You can actually choose as many as you want. I'm choosing only 4 because it's simple and comfortable for me. This is my first time working in Stata. So yeah, and you're gonna search for your variable name from there. There are a lot of actually every fields and information here are that you can choose. No, it's not GDP per capita. Also, there was, yeah, here it is. Then say copy, go to our list, and paste it. So here, guys, after we did this, we need to delete some rows there, which we don't need. We don't need the first row here, country name United Kingdom, because we all know that we're working in the United Kingdom. And we also don't need country code. We're gonna delete it. And indicator code. We don't need this also. So after deleting it, we need to name our data like simply, which will be understandable for us. So as we can see here, years. I'm just gonna say simply year. Oh, it's in Russian. Yeah, and here we can just say transport service, which is simple easy and understandable. And here, we're just gonna make it simple. Per capita. So yeah, after doing this, that's all that we're gonna do. That's the end of our work. Yeah, the last thing that we need to delete the data page because we don't need this page anymore. We got our own variables and data here. So yeah, I'm gonna delete this page just by clicking the right button of the mouse. Yeah, and then in the next video we're gonna talk about how to make our Excel format of our data into DTA file instead. So bye guys. Hello everyone, today we're gonna learn how to make our DTA file in setup. So first thing that we're gonna do is go to file part and say import here and say Excel spreadsheet. So here we're gonna choose our Excel, which we edit and did our own list. We're gonna choose our Excel file and say open, and then we're gonna press the import first row as variable names. I'm gonna say yes. So after we did this, here we can see the variables. Variables are appeared in those part of the set of windows. So we just got to see if there is anything wrong with the DTA. Spitting prompts. Yeah, here we can see that those numbers are in black while these years are in red. So this means that Stata considering those years as an average term. So we can fix it. We can fix it. So how can we fix it? Just to fix it, we're gonna press data. Here we're gonna go to change or create data and then choose other variable transformation commands and choose convert variables from string to numeric because we are working with the numeric variables right now. So here, if I press this, we're gonna get the string variable and we need to give it a new name. For example, years with an S. So yeah, I'm gonna say okay here. As we can see there that our new variable is generated. So we're gonna again browse and see. Yeah, here we can see that this data generated again, but it's good. So that means that we're gonna delete the year, which is in red. So you can type there just by saying drop year, or you can drop it just by pressing over the year. Here you can see it drop select variable. So yeah, I'm gonna say yes there. And again, we're gonna browse. Yeah, here we can see that everything is good with our DTA. So after we did this, we need to save it to the place that we're gonna find, that we can find. Yeah, we can just say save. And I'm gonna save here, UK DTA 2, and say save it. So yeah, that's how you can create your DTA format in Setup. Bye guys, in the next videos we're going to learn more about Setup and how to work in it. Everyone, today we're going to learn how to work in Setup. So to work in Setup, first thing that we need to do is installing the Setup, and after you're done like installing Setup, you need to open it, and if you open it, you're going to get this view. So the first thing that we need to do in Setup after opening it is like creating a log file. So to creating a log file, there is two options actually. You can go over this button and press it once, or you can go over file and go to the log part and press begin button. So for me, the first option is more comfortable. So I'm gonna press it once, and you need to give it a name like as you want it. And you need to make it in a log format. So you need to go to the next row and press it once, and you need to press the second option here, and you need to save it to the place that you can find. Here our log file is created. So log file is approved to our commands, and if we did all the commands, and it will, and our correlations, regressions, and tables also going to be appeared in our log format in our log file. So next thing that we need to do is opening a DTA file. If you don't have if you guys don't have DTA file, you can go to my previous video about about importing DTA file Excel into DTA file. So you can here get how to get DTA file there. And after you're done creating DTA file, you need to go open here and choose your data file, guys. Mine is UK. You need to press it. Press this open button too. Here we can see in the right side of our setup, our variables are appeared. Just to check if everything is good, we need to press BR, use browse button, and press enter button here. So we're gonna be able to get into data editor. Here we can see our data are appeared in data editor. So we can see that all of our variables are in black. So that means that everything is good with our data. And even if it's in blue, that means that everything is good with our data. But if something is in red, if your any data of yours is in black, that means that there is some error things. So you need to fix it. I also showed how to fix your error data in my previous video. So after that, we need to open the file, guys. I already created my do file, so I'm gonna open this. So it's gonna be easy for me to do my work and productive. Like you need to go over open, and you can go over your you can like open your do file here. Here we can see that I already give the log begin button, browse button, and the next thing that we need to give is ssc install install. So we're gonna give this command even like when when it's your first time in Stata. So like when it's your first time opening Stata, you need to give this command. So you can give this command if you have internet connection, and if you don't have internet connection, you can give this command, and even if you give it, it's gonna be error. So that means you need to install stock, which is like Word document. So if you install it, you're gonna be able to get your tables, correlations, and regressions in a document. So the next thing is gonna be, the next command is gonna be this option. You can guys give your command just by staying in the file also. Like you're gonna choose some point of it, and press the execute button there. Here our command is gonna be appeared in our status windows. So here you can see you can actually say just assume some button, some command, and you're gonna give a stock when you want your table or your result in a document file. So you can get into document file just by pressing this my file doc button. Let's get into this document. Here we can see the descriptive statistics. You guys gonna get this view. Like I already did some, and there's 3 of this. So what does this descriptive statistic means, or summarization table means? So here we can see, starting from the first column, variable. This is our variable's name. So, and next column means observation number. For example, for observation number for field impedance was 61, and observation number for transfer service was 53. So our next column is mean. Mean means the average point, or like the middle point of this variable. For example, middle year was the 1991, while the for field impedance, like average point was 9. And same thing with other variables too. So the next column is standard deviation. Describes standard deviation. Standard deviation means how far or close your variable to the mean, to the middle part, to the middle point. So year is 18 point far and close to the mean, and for GDP per capita is 10,614 point far and close to the mean. So same with other variables too. And this min means minimum point. Minimum point for like true inverse was 2, and same things with other variables too. So max is next column, and the last column here. Max means maximum point. For example, the maximum year or the last year of this data was 2022, and maximum point for GDP per capita, maximum sum you can say was 47,491. So that's how you're gonna describe this table. This was the definition of this table. So you're gonna copy this, guys, and go to your file, research file, and put it to the analysis and results part. As I already put it, guys, paste it. I don't have to do it again. So after you like copy and paste it, don't forget to close your do file, guys. So after like closing your do file, you need to go again to setup and give the next command. So the next command is tset years. You're gonna give this command only when your data is time series. So your data will be time series when you have year in it. Like I have year in my data, so that means it will give this tset here command. So you can also give this command, like select this command and copy this, and come to the command part and paste it and press enter and get the command. So here we can see that this is a result. This is a result. So this says that the variable is in year. variable year is starting from 1962 and ending in 2022. If you give this command, you will be able to like you'll be able to give the command line graph. Just to get the line graph, you need to give this two-way CS line command here. And here is our line graph. So my dependent variable fuel input is appeared in y-axis, and here is appeared in x-axis. Here we can see the trend that was during the period 1960 and 2022. Here we can see that fuel input actually grows between 1960 and 2022 to the, we can say, 10 points. No, not like 10 points, to 5 points. It grows to 5 points, and it reaches peak point to when it's like 1975 with 20 points. And you're also gonna copy this from this button and go to your research file and put it to the analysis and results part. Here we can see I already put all of my results there, so I'm just gonna quit this. So our next command is like same. These are the same commands, not like the same, just our variable is like change it there. So next command is gonna be scatter. Select this and give. So scatter plot. What does scatter plot mean? Scatter plot means describes the relationship between the dependent and independent variables. Here we can see my dependent variable is fuel input, and it's always need to be in y-axis because dependent variable needs to be in y-axis, and your independent variable needs to be in x-axis, which is transport service. Here we can see the relationship between transport service and fuel input. For example, when transport service reached, like we can see, 33 points, fuel input reached its 11 points. Here's the relationship. And we can here is the relationship between dependent and independent variable there. We also go and copy it and put it to our analysis and results parts of our research. So you're gonna give this command scatter, and after saying scatter, you always need to give your first dependent variable and then your independent variable. You're gonna give this command with other independent variables, and our next is two-way scatter. Here we're gonna get this two-way scatter. So it's also a relationship between fuel input and transport service, and this describes if it's a positive relationship or negative relationship, or there is no relationship between those two variables. So here we can see that fuel inputs and transport service has positive relationship. We're gonna give this this by looking at this line, red line. As it grows, we're gonna say it's positive relationship. If it were like dropping, we would say it's a negative relationship. And if like the red line will not be shown, that means that there's no relationship between those two variables. So we're gonna copy it and paste it to your analysis part in your research. So you're gonna do this with your other variables too, and you can combine your graph just by giving this command here. So next, we're gonna give the command PUV which means pairwise correlation. And here we're gonna get the pairwise correlation. So what does pairwise correlation means? Pearson pairwise correlation, the full form is. So Pearson pairwise correlation actually defines the relation or the correlation between your dependent and independent variables. So here we can see like 1 year increase in fuel input is gonna negatively react to year with 30%, and here we can see that 1 year increase in fuel input is gonna positively react with 45% to transport services, and to GDP per capita, it's also negatively react with 35%. And you can say it's significant when your p-value, which is this, is this will be, which is this is below than 0.005. So here we can see that our that this is like significant, and transport service is also significant, and the year is not significant. Or the same thing with these variables too. When you're like when you increase in transport service, it's gonna negatively react to GDP per capita with 94%, and it says that it's significant. Here we can see the significant p-value there. So our next command is Spearman correlation. Spearman correlation. I'm gonna give this command. So here the order is concentrate guys. So when you're giving Spearman or Pearson correlation, first you need to put your dependent variable and then your independent variable. Like as you can see, I did this in the pairwise correlation too. I first put my dependent variable, which is Filbert, and then my independent variables. So what does Spearman correlation means? Spearman correlation actually describes the relationship, like monotonic relationship between like variables. And while the pairwise Pearson correlation describes linear correlation, linear like relation between your variables. So here we can see one unit increase in fuel parts is going to negatively react to year with 26%, or 1 unit increase in transport service negatively react with 96% to GDP per capita, or same things with other variables too, with other combinations too. So after that, we need to give a regression, which is the important part of our. Oh yeah, before the regression, here we have the histogram. We need to give this histogram. So here we get the result of a histogram. So histogram is a type of graphical like representation that displays the distribution of continuous variables, and it provides a visual summary of the data, and it shows how our values are spread, or how it ranges, and so all in all, it describes how our values are spread across like different ranges. So in histogram, in x-axis represents the variables being measured. So in x-axis here we can see that our year is being measured here, and in y-axis, it actually represents the frequency or count of observations falling in each bin. So yeah, that's what histogram actually describes us. So it's actually, so all in all, it's the data. It describes us if data are spread across different values or and ranges. And here, the shape, this shape needs to be in a bell shape. Here you can see it's perfect because it's in a bell shape. So, and we're checking it in kernel density normality. So when you're checking your histogram in kernel density normality, this means that there's a this means that kernel density estimations normality is a method actually that you can use to estimate the probability of the density of a function. So yeah, I'm gonna use this normality here in this histogram too. So you're gonna also copy this and put it to your Word file, and you can also put your other variables to histogram. Get the histogram of it, and then we need to give the graph box here. Command graph box. Let's give another variable, which is like GDP per capita. Let's see it. So here we can see our graph box of GDP per capita. So what does graph box actually means or displays? So graph box provides a visual summary of the distribution of data and allows for easy comparison between different groups and categories. So here we can see the graph box of GDP per capita, for example. Here it's the median. We're going to call this line, which is inside the box, median. So it's the mean point here. If you go to summarization part and see like mean point, you can get like 33,000 or something. Let's go and see it. Like to the there here, yeah. As you can see, the mean is 31,000 there. Here is the graph box of this per capita. That's like the median is the mean point, and this graph box gives us information about like 75% of data. And these two lines here are gonna called outliers. Outliers gives information, the 25% of information about the data. So and yeah. So with this outside that this lines outside of the box means like this means the maximum point, the GDP per capita point of GDP per capita, and this is the minimum value of GDP per capita. Here, if we compare it with the summarization, GDP per capita's maximum point was 47,000 and minimum point was 14,000. And if we go to graph box, here we can see this 14,000 was the minimum point, and this like 47,000 was the maximum point. So this like point are like out of this box, and they're like spends from this box. So yeah, this is a graph box and gives information about the about the comparison of different groups and categories. So our next comment is you're also gonna copy this graph box and go to your analysis part and paste it. So our next is Shapiro-Wilk test, which is a normality test. So here we can see the Shapiro-Wilk test there. So what does Shapiro-Wilk test actually describes? Like if the observed data is normally distributed or not. So here we can see this table. Here observation number and this W value need to be this W value need to be closer to 1. If it's closer to 1, that means that that the data is like stronger evidence in support of normality, while this is like goes like is like more like 0, is closer to 0. That means that this value is departures from normality. So here we can see the p-value here. P-value needs to be greater than 0.005, because if it's not, if it's greater than 0.005, that means that data are normally distributed, and we're gonna accept the null hypothesis. So if it's not, then here we can, if it's not, then we need to go to the HA hypothesis. We need to reject the null hypothesis. Go to the HA hypothesis. So our next comment is the regression, which is the main part of our search. So here we can get the regression. So here is the regression result here. So regression consists of 3 parts. First table, which is ANOVA analysis. So this ANOVA table analyzes residuals and error terms. And the second part is parameters. So parameters, the first thing that we can see is numbers of observations, which is 53. And here the F, probability of F is 15 points here, and the p-value of the F. So this F test here means that all independent variables in the model in this model have no relationship with the dependent variables. So our probability value needs to be lower than 0.005. So it's lower than 0.005. So it means that it's significant. And R squared. R squared means that our 48%, here we can see 48% of our data is of our dependent variable is described by our independent variables here, and other 52 variables are indicated by another variables. So and the other and the next parameter is adjusted R squared. So we're going to get adjusted R squared in our parameters when we have more than 30 observation number here. If we have like lower than 30, then we will not be given adjusted R squared. So it also means that our 5% of our dependent variable is described by this independent variables. So next parameter is root MSE. So this root MSE describes the residuals between one respondent and another respondent. It describes the residuals between two observants and respondents. So our next table is this. So here we can see the field inverse here, which is our dependent variable, and here we're gonna get the standard error coefficient here. This coefficient needs to be, so 1 unit increase in ER is going to possibly react to field inverse with 62%, and 1 unit increase in transfer service is going to possibly react with 56%, and 1 unit increase in GDP per capita is going to negatively react to field inverse with 0.3%. And so here we have the next column, which is t-test. T-test is, or we can also say the student test. So it describes that each independent variable has its own HO hypothesis, and this hypothesis p-value needs to be lower than 0.005. Here p-value needs to be lower than 0.05. It is lower, like 3 of them is lower, so that means that our data is significant. And if it wasn't, then we would reject HO hypothesis and accept the HA hypothesis, except GDP per capita. Our p-value, like the last value of the p, is lower than 0.05. So we're gonna stay in HO hypothesis. So yeah, and independent variables will not affect the dependent variables there. So our next comment is gonna be robust linear regression. It comes up here, robust regression. So you can see what's the difference between robust regression and like the regression, like traditional regression. So the difference between these two regressions is in the way they handle the outliers and like assumption violations of assumptions. So like robust linear regression provides more resistant approach to handle like outliers rather than linear regression. Here we can see that the values differs in those two regressions. For example, the value of the p-value in GDP per capita was 100, 0.100. And in p-value there was 300. And we can see the difference that it's like more resistant than this one. And this robust regression is more beneficial when the assumptions of normality is questionable or is like questionable. So our next comment is going to be the multicollinear test, which we're going to give was a set VIV. So what does that mean? So the VIV actually means variance inflation in this multicollinear test. So this function used for it describes the correlation between predictor variables in a regression model. So VIV is calculated for each predictor in this model. Here we can see that VIV value for like year was 28 and GDP per capita is 27, and for transfer terms it was 11. So when we do like arithmetic progress there, it's gonna be 2022, which is the main point here. Or so generally the VIV value should be greater than 5 or 10. It's considered like problematic to multicollinearity test. So our next test is ANOVA test, which we're gonna give comment with this predict Wahat. So what is Wahat? If we give this command here, we can see that our new variable is gonna be appeared in our into file. We need to see this just by saying browse and pressing the enter button there. So here we can see our Wahat. So what does that Wahat means? So Wahat means that in the Wahat represents the predicted value of dependent variable based on a regression model. And in this regression model, the predicted value of dependent variable is going to be expressed by the formula that represents the coefficients of the estimated coefficients plus the coefficients and the values of independent variables. Here we're going to get this result by doing this formula. So Wahat is expected or estimated value of the independent variable, all in all, and like given specific values of the independent variables according to regression model. So the goal of regression analysis is to minimize the difference between the observed values and predicted values. So that's why obtaining the best fitting line or curve that represents the relationship between variables would be actually beneficial. Our next comment is going to be histogram. We need to also make histogram and graphbox and SWOT for this Wahat also. Let's see the Shapiro Wilk test for Wahat. Here, as you can see, the p-value here is lower than 0.005. So that means that this our data is that we can accept the HO hypothesis. And the next command is going to be predict IHAT here. But before giving predicting IHAT, we need to first give regression. Then we can give this command here. Here we can see that IHAT is appeared in the right side of our data. So we need to browse just to see the result of the IHAT. Here it says, so what is actually IHAT is? IHAT is the residual or error term that is calculated, and so this residual term or IHAT represents the leftover or residuals variations in the dependent variable that regression was not able to capture. So yeah, it reflects the extent to which predicted values divide from the true observed values. So yeah, it represents this difference between the observed and predicted values in a regression model. Here we can see the results of which is error terms. We're also going to make histogram. After doing all of these things, we need to do log close, guys, just to get our log file, which we're going to do from there. And we need to choose the close log file button and press OK. Here our log file also is created. So bye guys.